Alright, Assalamualaikum and good day everyone. So today we will look into uh, the example question from September 2015. The question states that air at an initial state of 300 Kelvin, 150 kilopascal and zero point 0.2 meter cube is compressed slowly in an isothermal process to the pressure of 800 kilopascal. Then air undergoes heating process at constant pressure to reach 400 Kelvin of temperature. So this question requires you to sketch both processes on a single PV diagram showing the direction of the processes and label the states. And they also requires you to determine the final specific volume at the end of the heating process. And the answer should be in meter cube over kilogram. So as usual, first we are going to look into the substance from this question. So here we can see the substance is air and it will be considered as the ideal gas. Thus, for this particular question, we are going to use the equation of formulas to solve. Alright, so next, let's list out all the informations given from this question. So given over here is T1, P1, and also V1. This will be our P2 after having the isothermal process. Then the air undergoes heating process at constant pressure. So this will be the second process. And this will give us the information for T3. So you need to list out state 1. So we have P1, 150 kilopascal. T1 given 300 Kelvin. V1, 0.2 meter cube. And then we have state 2. This process undergoes in isothermal manners. So we have over here T1 equal to T2. And then we have P2 over there, 800 kilopascal. And then we have another process which gives us state 3. From state 2 to state 3, it will be in isobaric. So we have over there P3 equal to P2 equal to 800 kilopascal. And we have temperature at state 3, 400 Kelvin. All right. So let's solve the item number 2, which we need to determine the final specific volume at the end of the heating process. So we have over here is the V1. So we can use the relation P1 V1 equal to P2 V2 in order for us to find the volume at state 2. So this will give us the volume at state 2, and you're going to get 0.0375 meter cube. All right. So next we are going to find the volume at state 3. So since we know that the process from state 2 to state 3 undergoes the isobaric process. So we can use this relation V2 over T2 equal to V3 over T3. So V3 is equal to V2 over T2 times with T3. And then we substitute with the data that we have. Will give us the volume at state 3, right? So for this, you're going to get the volume at state 3 is 0.05 meter cube. But please note that this question requires you to determine the specific volume, meaning it should be in the unit of meter cube over kilogram. Thus, we need to divide the volume at state 3 with the mass. Right. Since we don't have the value for the mass given by the question, since we have all the data required, especially for state 1, with by using the ideal gas equation of state, P1 V1 equal to mR T1, then we can find the mass. Mass will be P1 V1 divided with R T1. Okay, so we have the value for P1, we have the value for V1, and also we have the value for T1. However, from this question, it's not been given the specific gas constant R for the air. You can just look into your property tables. Okay, you can go to table A2. So we have the gas air and we have the gas constant 0.287 kilojoule over kilogram Kelvin. So you substitute all the data that we have, and you're going to get the value for the mass. So for the mass, you're going to get the value of 0.3484 kilograms. Now, the specific volume at state 3 will be given by the volume at state 3 divided with the mass. Right. So for item number 2, we already complete, we already obtained the specific volume at the end of the heating process, which is at state number 3. So now let's draw or sketch the PV diagram that represent all the two processes involved in this particular question. So your PV diagram should look like this. Okay, so we have from state 1 to state 2 in isothermal manners, and then we have from state 2 to state 3 in isobaric process.